Hello and welcome back to Elementary Algebra section 5.4 on special products. So this will be the end for chapter 5. The rest of the sections will be covered in intermediate algebra if you continue that route. And this is on formulas which, if we memorize them, will help us skip a lot of work. So here is the idea. If you multiply two binomials, this is what we did before. Let's say x plus 3 times x minus 6. If you multiply these, you will get 4 terms, and then maybe you can collect like terms and simplify it more. So x times x is x squared, x times negative 6 is minus 6x, 3 times x is positive 3x, and then 3 times negative 6 is negative 18. Now we see that we can combine these middle terms here, get x squared minus 3x minus 18. So this is what we did in 5.3. Now, I can take a look at the problem x plus 3 times x minus 3. This problem looks exactly the same as previous problem. It is binomial times binomial. And you know how to multiply this. All right, go ahead and multiply this one. Let's see what it simplifies into at the end. So 18 seconds on the clock. Go. So what do you have?
X to the second minus 9.
Excellent. So when all is said and done, it cancels those terms with x's. We're going to obviously do all of the details, but what happens is it cancels down, and you will see that when you have this type of a question where the parentheses have the same terms and just the sign is different, it is going to be one of the special products because those will always cancel to that simpler form. So let's first do this problem and then take a look at the formula and then do more examples.
It's a special product because why?
Because they look the same, they have the same terms, x and a 3, and then the sign is opposite. But we'll put that in a formula, it will be clear. X times x is x squared, then x times negative 3, that's negative 3x, then plus 3x, and then minus 9. These two cancel, and you get x squared minus 9, which is exactly what you said earlier. So this is called a special product, and it's called product of a sum and a difference, and it has this formula which you can use to jump from here there, skipping all the calculations. So if you memorize the formula, you can immediately make the jump without calculation. That's why we are learning these. So the first out of 3 formulas is product of a sum and a difference. Product of a sum and difference. And it goes like this. A minus B times A plus B is equal to A squared minus B squared. So this is a formula, and it is very easy to use it. Y minus 5 times y plus 5. So this is a requirement. These two have to look the same, and they have to have opposite sign. So y has to be the same as a y, 5 has to be the same as 5, and then the sign, one has to be plus, one has to be minus. It doesn't matter which one is plus, which one is minus, because it's multiplication, so it's commutative, right? We can put each one of these, either one first, because it's multiplication in between, right? Now look, when you have this form, so y is the same as y, 5 is the same as 5, this immediately tells you that a from the formula is y and b is 5. So you can just write the answer immediately. A squared, that's y squared, minus, and b is 5. 5 squared is 25. And you skip all of the other calculations. So you use your parenthesis with the minus to extract a and b, and then you just stuff those a and b, square each one of them, and you have your answer immediately without that middle calculation and canceling and all of that stuff. So these problems are really, really quick and cool if you memorize the formula. Let's take a look at another example. Let's say 2x plus 3, 2x minus 3. Okay, I have 2x, 2x, and then 3 and 3. So this is a special product situation. And all I need to realize is that A is 2x and B is 3. The result is always a squared minus b squared. So 4x squared minus 9. When you square 2x, the rule that we learned in 5.1 was that each factor of the parenthesis gets its own square. So it's 2 squared and x squared, which creates 4x squared. So that's how that becomes 4x squared. This power will go on each one inside the parenthesis. That was rule number 4, I think. Rule number 4 in our 5.1. So once I have determined that I have this situation of the special product, all I need to do is to figure out what a and b are, and then just calculate a square minus, and then put the b square, and we're done. Let's take a look at some examples that are presented in a homework in a book. So they want us to calculate two x plus 3y times 2x minus 3y. All right, now you all you get is 7 seconds, because right, you either know the formula or you don't. There is no in between with this. What do we have as the answer?
4x squared minus 9y squared.
Perfect. Now, how do we get that? This is my A.
Oh.
And that's my B, right?
Yeah.
So 2x squared is 2 squared x squared, which is 4x squared. And then 3y squared is a 3 square y squared, which is 9y squared. Awesome. Now, obviously, you do not have to write any of this stuff here, right? You are allowed to write the answer directly for full credit, because that's why this formula exists, right? To skip over all of the calculations and steps and so on and get us directly to the simplified answer at the end. One more example from the book, and then we go to the next rule. There is really not much to this, as you can see. Pick up your a, pick up your b, square them, and you're done. 3x squared plus y squared. And over here we have y squared minus 3x squared. Why did I write the word evil over there?
Because you are sometimes.
Sometimes?
Just sometimes.
If I was to get offended, I would be offended, but unfortunately, I don't. So, what is weird about this problem here?
Like inverted, kind of.
Yes. See that the over here y squared is first, and over here y squared is second. Now, luckily, that's not a problem for us, because addition is commutative, so we can flip it around.
Oh.
Addition is commutative, so we can just write this way. We can't do this with subtraction. Subtraction is always the way it is. But addition, you can flip. And now you have your A, you have your B, and you can just write your answer right there. So what do we have?
Negative 9x to the fourth plus y to the fourth.
Okay, I mean, it's correct.
Oh, sorry, I like skipped everything.
You didn't skip everything. You just put the second term first with a negative. Not sure why. You have your y to the fourth first, and then minus 9x to the fourth second.
Where do we get the fourth from and why? Oh, I see.
Square, right? Square.
Oh, okay, that's where.
The rule.
Got to square it.
Yeah.
Is there a reason why the y is first?
Because y is a. It's listed first in a subtraction.
I solved it.
Yeah, subtraction is the boss here, because subtraction cannot be flipped. So some students, after doing a couple of these problems, they say, oh, so we can always look at the parenthesis with the minus and pick our a. And it's always going to be a is going to be whatever is first in a subtraction parenthesis. And I have to say yes, because that's correct. The subtraction parenthesis is always a minus b, because you can't flip those around. Now, the addition parenthesis, you can put it in any order. Now we have seen in this evil problem that we had to flip addition so that we can match what's first, what's second with the subtraction parenthesis, but the subtraction parenthesis was not changed. Therefore, if you look for your a and b, you can always look for your a and b in a subtraction parenthesis, and you don't even have to flip the addition at all, because your a is y squared and your b is 3x squared. And then, since your a is y squared, then your a squared over here has to be y to the fourth, which is the first first term that we have to have. It's a squared. So that was a little curveball there, but we managed to get through it. The last concept for today's class is what we call squaring binomials. Let's put this. And that's exactly what it sounds as. You have a plus b, everything squared, which will give you the formula a squared plus 2ab plus b squared. And the one for minus, which is the same formula with the minus on 2ab. Again, your job is to pick up a and b and just plug them everywhere. But actually, no, let's do it immediately. So how about x plus 6 squared? So my a is x and my b is 6. So I just need to plug them where they belong, right? X goes in there, becomes x squared, plus 2 times a is x, b is 6, plus b squared is 36. That's a 6 squared. And all I need to do is to fix the middle term, and we're done.
Can you go over that one again?
Yes. It's all gone now. So once I see the problem, immediately the form of the problem matches.
Mm-hmm.
And we know that a is the first and the b is the second, whatever this is. So now the solution is a squared. Well, that's going to be x squared, plus 2 times a is x, times b is 6, plus b squared, which is 6 squared. And now we just simplify.
I'm confused. Where did you get the 2 from in the middle?
From the formula.
I got the
Now I'm going to show where the formula comes from, but if you compare this term by term, here's your a, here's your 2, here's your a, here's your 6, here's your 6 squared. And we just plug them in the way they are.
Does this formula have a name?
The name.
Just squaring binomials?
Yes, because that's exactly what we're doing. There is a square on a binomial. Now, what that means is we are multiplying binomial by itself. So if you are to write this out and multiply the way we did it in the last lecture, x times x is x squared, x times 6 is plus 6x, then we have this, 6 times x is plus another 6x, plus 36, and you see that the middle one is twice, right? So that's where the 2ab comes from in the formula. So do you need to memorize the formula?
Yes.
Not really in chapter 5, because you can always cheat by basic multiplication. However, you need it for chapter 6, so the sooner you learn it, the better. let's take a look at more examples. So 3x minus 4 squared. Okay, I'm going to solve this one. Please pay attention, right? Look at this, and then we'll have one for you right after this. So my A is 3x. My B is 4. And the formula, when I have a minus there, I memorized it. A squared minus 2ab plus b squared. That's what I memorized. So now I have 3x squared, that's a squared, minus 2 times a is 3x, times b, which is 4, and then plus b squared, which is 4 squared. So every a is replaced with 3x. Every b is replaced with 4. And the rest, the signs and the 2, that all stays as is. And all I need to do is to work out this arithmetic here to fix this to look nice. So 9x squared, 3 squared is 9, and then x squared, minus, and now 2 times 3 times 4, well, that's 24x plus 16. So if I was to, multiply 3x minus 4 times 3x minus 4, I would get the same answer, except I would have to write everything out and then collect like terms and all of that stuff. So this formula...
Wait, where did you get the 24? I'm sorry, I just like...
2 times 3 times 4.
Okay, so you always do that? You always multiply the
You simplify everything,
separately, right? And then add the x?
Yeah, you want to simplify everything, so you don't have to do any other calculations, right? You have the least amount of operations left, right? That's the most simplified answer you can get is when you square the 3, you get 9x squared, then 2 times 3 times 4 is 24, and then 4 squared is 16. So there is nothing else we can do here. We can't do any like terms because none of them are like. They'll have different exponents. So that will be the end of it. So let's do one more example and call it a day. 4x plus okay, there we go. Tablet, we okay? I guess we are. So 4x plus 2ab everything squared. All right, can anyone give me the answer that it's like the end?
Is it 16x squared plus 16x plus 4?
What happened with A's and B's?
Oh, snap.
It's 2 times AB. So that means 8. And 8 and 8 is 8 times 8 is 64. That's what I went.
Okay, so now let's go. Let's do this. I'm going to use capital A and B now because A and B are used in the problem. I like the start over here. That's correct. And then kind of went a little bit downhill there, but we'll fix it. Not a big deal. So let's go. So my capital A now is 4x and a capital B is 2AB. And the formula will be A plus 2AB plus B squared. So we just A squared. There we go. A squared plus 2AB plus B squared. So now 4x squared, that's capital A squared, plus 2 times capital A, that's 4x, and then capital B is 2AB, there we go, and then finally plus 2AB squared. And now we simplify this. 16x squared plus 16xab or abx, or I really don't care which order you put this in, plus 4a squared b squared. And now the $1,000,000 move, put them in descending order because the order is exactly opposite in this one. See, the 4a squared b squared has 4 variables. The middle one has 3 variables, and this
I have a
one has 2.
question. How did you get, I understand how you got the 16x squared. Where did you get the 16 from? Wouldn't that be the 2 times 4x? Wouldn't that be 8?
And then times 2. 8 times 2 is?
Oh, so 8 times 2 is 16 xab. Oh, okay. 16 plus the 4. Okay, wait. So I understand the 16 xab. So the 4a squared. So the 2 times 2. Okay, 4 a squared b squared. Okay. That's a lot.
Its own square, right? That was the rule we had in 5.1, where each member of the parenthesis gets its own square if they're multiplied. So that's exactly what happened there. 2 got its own square, A got its square, B got its square, and then 2 squared is 4. That was the rule from 5.1.
Are we breaking this down again to get the 4a squared b squared?
No, we're done. Once you calculate, you are done, except now, when you look at the amount of variables, right, to put them in a descending
Wait, no,
order.
I'm sorry. The second line after the 16x squared, the line underneath that, what is that?
It's descending order of powers.
Oh, the descending order. Okay.
Because this one has 4 variables, this one has 3 variables, this one has 2 variables. So they were all backwards the way we calculated the problem. So we just had to fix it.
So that's the descending value. Okay.
Just reordering them. I think my MATLAB will fix that for you.
So the sets are whatever's in between. I'm sorry. The sets are everything like in between, like the symbols, like the plus and the minus sign. Those are like the groups.
Yes. So 1, 2, 3, 1,
Okay.
2, 3.
Okay, so it's 3 groups. Okay.
You start, yes. So this is your a squared, 2ab, b squared. And that will be it.
Okay.
So the homework is posted. You can go have fun there. And then on Thursday, we are going to review the entire chapter and then do 6.1 on Thursday as we get into the next week. So I would say 2 weeks to finish chapter 6. I like to take the time with that because it's factoring. So it's technically, breaking these apart into this stuff. So we're gonna go backwards. We have to learn all of the rules and stuff like that. So we'll take our sweet time with chapter 6 to make sure that's all perfect. Hopefully to have that exam 3 before Thanksgiving, so that after Thanksgiving we can only focus on exam 4 and a final, rather than having 2 exams and a final in those 3 weeks at the end.
Too many exams.
Yeah, they have 4 exams plus final. That is 5 exams in total, and that is a standard for this course. So every instructor is required to put those exams the same way, the same amount and everything. So I don't know if it's the most efficient or not, but that's what we have. And I'm just trying to, make sure that you guys are having them spaced out enough so you don't have, exam each week going into the last 3 weeks of the course. So hopefully, it's all gonna be spread out and nice and easy.
Okay.
See you Thursday.
Thank you for your
Bye.
time.
You're welcome, and I'll see you all on Thursday. Bye.